Well, good morning, good afternoon, or good evening, depending on where you are. My name is Matt Mangriotis, Director of Product Management. And today we're going to talk a little bit about dynamic shared access spectrum. It's a mouthful, but what it means is the ability to share spectrum among different users. And it's a really important concept to help alleviate some of the problems that are associated with the lack of spectrum and the lack of the ability to use existing spectrum. Spectrum is kind of like land. They're not making more of it. They're just using more of what's there. And at some point, we're going to run out of spectrum. Just totally run out of spectrum. So the ITU, this international organization, has been working on identifying and assigning spectrum for 5G use. Back in 2019, the council has designated more than 17 gigahertz of spectrum for this purpose. There's a link there. You can check it out yourself and kind of see what they've been saying as, hey, this is set aside for 5G. We'll figure out how to use it, but this is kind of what we think we can set aside for 5G use, so to speak. And at the end of the day, is it necessary to use 5G in this spectrum? Probably not. What the goal of this is to kind of allow more users in these chunks of spectrum around the world. Implementing this and getting it to those users or to having the ability to utilize broadband in these frequencies is very difficult, and it's challenging for a number of reasons. It's really hard to get these chunks of spectrum freed up. Really, how can we make it easier? And sharing the spectrum in a manner that makes it easy is probably a better answer than allowing local telecom regulators to either license it, and there's a couple of reasons they would license it. One is to protect folks that are using it. Another is to make money, right? A lot of governments want to make money selling or leasing this spectrum to the potential users. In order to better utilize the spectrum or share it among more people, it might make sense to have a sharing model, and a dynamic sharing model makes it even easier. So internationally, I mean, I'm from the United States, so I'm very familiar with what the FCC is doing for all these things. Are they right? Are they wrong? Opinions out, and sometimes they're better than others in some spectrum, and some spectrum maybe we think they did the wrong thing. However, internationally, there's lots of different pulls and pushes on why they're doing what they're doing. And again, they could be out there to make money as a government or as a regulator agency. They could be out there to protect who's using it now, whether that's legal or not, and then maybe they make it legal by changing the regulations. Spectrum sharing can provide an avenue to using that for more users to be able to use that spectrum, avoiding these complex licensing schemes or very expensive licensing paths. And they can protect incumbents while doing this. So if there are users that we need to protect, there's ways to do that, and we're seeing that in play already. So opportunities, where are the opportunities in a general sense? TV whitespace seems to be becoming more popular. This shift to digital TV transmission over analog, the digital channels are much smaller. They're more narrow. They fall off more rapidly. And around the world, this transition has happened or is in the process of happening. And so a lot of this analog TV space that was reserved is freed up for other use. And it's prime spectrum, right? This is low frequency, relatively speaking, low frequency spectrum that can be used to travel a long distance. So we do need to protect those existing and legacy TV stations that are still doing digital transmissions, but there's a lot of white space in between that can be used for broadband. Now, we'll talk more about that. CBRS, mid-band spectrum. It's been successful so far. So the US launched this. They had a plan going back 6-7 years. They launched it last year in 2020, and it's been successful. We have tons of people using it. Again, we'll get into more details in a minute, but it's that CBRS band, so-called CBRS in the US, is a mid-band spectrum. It's in the 3 gigahertz range, and that's set aside in a lot of countries, in a lot of areas internationally, for 5G opportunities. And so this mid-band spectrum is something that's being talked about in many locations. The next big thing, 6 gigahertz. So today we have 5 gigahertz as an unlicensed band. It's kind of a globally recognized unlicensed band. In almost every country in the world, you're allowed to use 5 gigahertz as an unlicensed. Anybody can use it, and it's shared. It's not regulated in any way. There's EIRP limits, of course, but it's not really regulated. So if you cause interference, you must resolve that interference on your own. You cannot cause interference. That's kind of the rule. 6 gigahertz, hopefully, in a lot of areas, will be treated the same way. I think the US is pioneering the use of this. There are a couple countries that have up to about 6.4 gigahertz available already today. I can think of a few off the top of my head. And even in unlicensed, I think Russia uses it in an unlicensed fashion up to 6.4. But more and more countries are seeing the availability of the underutilization, I should say, of 6 gigahertz all the way up to 7.125 as an opportunity to allow more folks to get on the band and use it. Now, in this band, in 6 gigahertz, there's a lot of licensed users, licensed 6 gigahertz users for microwave. Those folks need to be protected because they paid a lot of money for those licenses. And so there's a plan to do so in the US, and we'll talk through what that plan is and then how it's being thought about in other countries. And Wi-Fi 6E, I list that technology there. Now it's not dedicated to that, but Wi-Fi 6E as a chipset will be able to support this new frequency. And so that's a kind of a key driver or an ecosystem driver for the use of that spectrum around the world. Millimeter wave. So lots of opportunities in the higher frequencies. So as you go up past the 40 gigahertz range into the 60 gigahertz, which is unlicensed in some areas, 70 gigahertz, there's a lot of opportunities up in these high frequency ranges that could be very conducive to using this sharing method. And there's a lot of places that could be freed up in the future that really haven't even been thought about yet. So let's dive a little deeper on TV whitespace and talk about what that means and what the opportunities are. So where are the opportunities? There are quite a few already. In the US, of course, was kind of the first one to adopt it. Canada's adopted recently. In the Caribbean, we have a couple of Trinidad and Tobago. Colombia's introduced it. UK, even Korea and Singapore have had regulations put in place for white space. And then there's a few countries in Africa. The ones with the black, they have consultations published. Brazil is a big one that potentially will get going. But a lot of these things are still in process. And I will say that Cambium, actually back then it was Motorola, but we did have a product that operated in TV whitespace bands way back when they first started talking about this. What our problem was we couldn't make it inexpensive enough to be, usable by an operator. They had very tight. There was several regulations around the band that made it super difficult for us to produce something that made sense for an operator to use. Very tight emission mask. There were restrictions on the heights of the subscriber modules, especially. Channel sizes are very small, 6 megahertz. So could you get enough bandwidth in 6 megahertz to do what you needed to do? The database for administration purposes, for protecting those TV stations, was tough to come by, expensive. There was only one guy doing it at the time. All of these things have gotten better. And so the future is definitely brighter for TV whitespace. A couple other factors are that the antennas, when you go down in these low frequencies, and we're talking about 500 megahertz, 600 megahertz, the antennas are enormous. So they become really big if you want to get the distance that you need to make this work. As things progress and as these regulatory restrictions are mitigated, as the nature of the discrete packages and circuitry becomes a little bit easier to manufacture, a little cheaper, things are getting better, and the opportunity is becoming larger because it's being recognized as an opportunity in more areas. So things could change. We could have a product in TV whitespace in the future. We don't have one today, but certainly TV whitespace is something to keep an eye on for the future. I don't know of anyone having great success and deploying this as a primary product, or they're not using this as their primary bands, but because of the propagation nature of TV white space being this very low frequency, it is useful in some scenarios to do these long shots or difficult shots, non-line of sight shots to customers that need that connection. So opportunities are there. Keep an eye on it. Not a primary band for most people, but it's an opportunity. Shifting gears a bit to CBRS, or mid-band spectrum. Really, again, I just want to highlight that dynamic spectrum sharing can be used to any spectrum globally. And this tiered approach that's in the CBRS band is really what's been driving this. It is complex. It's not a simple thing. Anyone who's a CBRS customer today, if they're listening on the phone today, in the US, it does take some learning to get it right, to do it right. It allows the lower frequency than 5 gigahertz to be used, which is better penetration, better propagation techniques. It does allow higher power than 5 gigahertz. And the spectrum is actively managed, meaning you have to be using equipment that supports that SAS, the management database. If you're not technically allowed to be on that band. It does protect incumbents, and you can buy this license, this priority access license, for priority use of the band. It comes at a cost, and it really is a little bit complex. So you got to know what you're doing. It is a bit of a learning curve, but it is, in my mind and a lot of folks' mind, successful. We've seen it for about a year now, and it is successful. We have hundreds of thousands of devices operating in the band, and things are looking good. To kind of summarize what that CBRS band has done, if you look on the left side of the slide, the opportunity that was there, meaning what was in place before, was a lightly licensed 50 megahertz of spectrum in the 365 band. They've opened that up, added 100 more megahertz, and required this tiered use, meaning that most folks are using it in general authorized access mode, GAA mode. Most users do that. Across the country in the US, they sold priority licenses by county. So there's lots of different licenses localized. And they sold those to these folks, and it's a 10-year lease, basically, a 10-year license. And those folks will get priority access in 10 megahertz chunks. So they could have bought up to 4 of those in any given county. Were they expensive? Probably for some, but some folks wanted that protection, that priority license use. And then the incumbents, they still wanted to protect naval radars. Anyone along the coast is susceptible or open to, if the Navy, the US Navy, comes in with a Aegis class aircraft carrier with radar, it will take away some of the channels because it's using that channel at the time. And there's a sensor network that senses these things and will move people off of those frequencies if that is required. And that's incumbent protection. So it is a complex system with several layers of use. They established a new TDD LTE band called band 48 to accommodate this. In most of the world, band 42 and 43 are still going to be used for the 3 gigahertz spectrum. So in most of the world, there's 400 megahertz of spectrum to use, and can be used in this sharing model. Now, and I will say that in a lot of areas of the world, a lot of countries, those two bands, 42 and 43, are already allocated to either mobile users or just strictly licensed, and may not ever see this sharing model adopted. But there are countries that are exploring that now. So this is another way to look at it. I won't spend a lot of time on this slide, but the general authorized access users can use the entire band. The incumbent folks are now gone. That green box in the second row from the bottom, those folks, all of the licenses, I think nearly all of them are expired. There's only a handful that are left. Most of them expired last October. Many more expired this February. So there's hardly any left now that are still incumbent users. And then the PALs will go into effect mid-April, or start to be rolled out mid-April. The folks that bought them know they have them. They're just not implemented quite yet. The system is catching up, and that implementation is expected to begin in a couple weeks. So just want to point out here that this is a proven way to share spectrum. It is working and it is successful. The 450 platform, for all intents and purposes, is the primary platform working in this band, and that's across all vendors, all technologies, everything. We Cambium are working with 3 of the major SaaS providers, Federated Wireless, Google, and CommScope. We work with any of them that you choose as a user. And so we have partnerships with those guys to manage this database. We have, again, nearly 100,000 devices operating in this band today, right now. And it's been a steady increase in number as we move along. There is a large ecosystem. I will point out that LTE-based equipment in 3 gigahertz band is popular. It's not nearly as high performance as the 450 platform, but it is available. And some folks look at that and say, I need a standards-based product. And so they want an LTE-based product. And eventually, those things are going to transition to the 5G technologies. We know that. And eventually, that's the plan for everything that we do as well. We're transitioning over to standards where it makes sense. It will take time, but that is the long-term strategy. And so I will point out again that one of the reasons they did this priority access license auction was to raise money. The FCC made $4.6 billion licensing off those county licenses, those 10 megahertz chunks of licenses. So regulators always look at that as an opportunity as well. So let's shift gears once more to 6 gigahertz. Why is 6 gigahertz being considered or an opportunity for license, excuse me, spectrum sharing? Wi-Fi is used in unlicensed bands. It's been that way since the beginning of this industry back in the early 2000s. Wi-Fi is commonly used in unlicensed bands around the world, 2, 4, 5 gigahertz. Those are the most commonly used ones. Now 6 gigahertz really it lends itself to operating under those same rules. But to use the Wi-Fi or unlicensed bands successfully or effectively requires some coordination. Cambium has done this with GPS synchronization, eliminating or mitigating self-interference so that you can effectively use what the spectrum is available in your area. License holders, if there are license holders, and there are in 6 gigahertz, as I mentioned, it complicates things a bit because you want to protect those folks that have paid money or have somehow paid or gotten licenses to use that band. You don't want to just start broadcasting unlicensed radios all over their spectrum. Wi-Fi 6 and 6E provide this new standard that does help with efficiency and performance and will likely be the predominant technology. I think Wi-Fi 6 in the 6 gigahertz band will be used most often around the world. However, again, I'm going back to the 450 platform, which I manage, so I'm a little biased toward that. But I think the SDR and the capabilities and the performance of that platform, we are going to adapt into the 6 gigahertz band. And I think that will provide an alternative technology that will outperform what's available in Wi-Fi 6. We can do lots of really technologically cool things with that protocol, with that technology that you otherwise can't do with a standards-based chipset. License holders, again, they need to be protected, and that's something that the US has considered, and they're doing that using an AFC, an automated frequency coordinator. Let's talk about what that is. So Federated has presented on this, and I borrowed a slide from them. They're going to be, or they have plans on being one of the AFC management companies. And so what that does is really, it's taking this coordinator, takes the FCC database, and again, this is what's happening in the US, but we see this model being propagated across wherever other countries want to do this sort of thing. The FCC has a database of license holders. They know where they are, they know the direction, the orientation that the devices are pointed, they know what type of devices they are, how much power, how big the antenna is, all that stuff. And so they have all that data information. This AFC takes a request from a new device that's coming online. and it says, okay, am I in the vicinity of any of those license holders? Am I going to interfere with any of those license holders? If so, then I move to another frequency. I won't allow this radio to work on this frequency, or I have to turn down the power, what have you. So there's a method of protecting those incumbents, and that is the only job of the AFC. So it's a less complex system than what's implemented in CBRS, but it's still there to protect those incumbents. And that's a good example of how we share spectrum without stepping on existing users. This slide I borrowed from Aruba, who presented on 6 gigahertz and what the various countries are doing. So there's a lot of different things going on. The key ones here are the FCC is planning to have implementation sometime in 2022. I know this one says there's a second report in order kind of at the end of 2020. There was a report in order issued, but to implement and get it commercially shipping is going to take some more time. So we expect this to be available commercially in 2022. And a couple of other important countries here listed are UK, and I'll talk more about them in a minute, and the European Commission. So that Europe is also debating how best to use this. At this time, it's not looking real good as far as outdoor high power use for the EU. They're considering it more as an indoor band, which kind of limits the broadband capabilities of it, but it'll still allow Wi-Fi 6 to be used as an indoor band in the 6 gigahertz range, which would be really cool for that purpose. But I would really like to see it used as an outdoor solution as well, like we're doing in the US, even if it means doing some kind of AFC and protecting those incumbents once more. So lots of countries have began evaluating 6 gigahertz. I mentioned 3 gigahertz as well. So there's, again, Japan and Korea are doing 6 gigahertz evaluation. Brazil is well underway and getting close to having open that up as well. So there's lots of opportunities for 6 gigahertz, and I think we'll see that Wi-Fi 6 technology come into play in a big way towards the end of this year and especially next year. So let's talk about some of the regulatory efforts in specific countries. Start with the UK. In the UK, Ofcom is the name of the regulator, and they're working on several different bands and really what they want to do is increase broadband coverage for residents, where they live, where they work, where they travel, right? So they want to increase the economic capabilities of carrying broadband. As everyone knows, broadband is kind of an essential service for growth these days. And so we mentioned some of the bands, but some of them we didn't really touch on yet. So they have opportunities in 2, 3, and 1800 megahertz, 1.8. So there is some opportunity there. They also have some opportunities in 24 to 26 gig. And I will say that we, Cambium, are developing a product that will support those bands in a great way. We're utilizing 5GNR protocols, and we believe we'll have a real good opportunity to make some inroads in that 24 to 29 gigahertz band, which, again, they're looking at spectrum sharing in the UK and in many other locations. They would consider that the low end of the millimeter wave band. But that certainly is being talked about in a big way in the UK right now. South Africa. South Africa is working towards spectrum sharing. They're very interested in it. They're a little bit further behind in terms of establishing regulations, but really they want to get the underserved and unserved areas of the country that are really hard pressed to have access to broadband. Right now, the 5 gigahertz band is really noisy. It's being well used out there, and it's overused. There's a really high noise floor everywhere in South Africa. It's getting tough to use unlicensed spectrum as we know it. So they are exploring kind of this tiered use system for various frequencies. So they're still in the evaluation phase, but really they want to implement something as soon as they can. Mexico. There's lots going on in Mexico. IFATEL has worked on lots of different bands. 900 megahertz is actually being used today in an unlicensed fashion and they may implement some kind of sharing to open that band a little more and make it more usable for more users. But right now they do have some areas where if you're an industrial customer, you can use some 900 megahertz, which is still, it is noisy. It's pretty narrow band, but it's still usable in a lot of locations. 2.3, they want to move some services around and then maybe open that up. That's a little farther out, I think, than anything else that's listed here, but that's being considered. 3 gig, they need to protect those fixed satellite stations, and I don't know how much of that will actually come to pass, but it's being evaluated. And then 6 gigahertz, I think, is the best opportunity for becoming usable by more folks, and that's probably after the US and Canada and some other countries get it in place, but public consultation is happening right now, and they are considering secondary use for TV whitespace. France, and I point out France only because we heard someone from the ANFR speak during one of the Wind Forum meetings, and so he brought the view or the vision of what's happening in kind of the overall Europe. CEPT there is the European regulation body, and they are working with them on 3 gigahertz band in general. And I think whatever happens, for the most part, in France, which is part of ETSI or the EU, will be common throughout most of the European countries. And so that's why I kind of point out that most of this applies to most of Europe. Again, 26 gigahertz opportunities there. Got to protect those incumbents that are using it for the space radar and scientific stations. But there's opportunity in many locations for 26, 28 gigahertz, and so that's being explored. 6 gigahertz, again, geolocation, I didn't mention this before, but knowing where the radios are goes a long way to identifying how and if you'll interfere with incumbents. And I think that's a key point, that 6 gigahertz, you're going to have to know where those radios are. So GPS locationing is useful, or some form of locating, geolocation of those radios. The system, the AFC, has to know where those radios are at all times. So 6 gigahertz is being explored by many countries in the EU. Australia. ACMA is the regulatory body in Australia, and they're looking at other countries right now. Nothing is there yet, but they're very likely, I think, to adopt a similar thing for 6 gigahertz as the US has or will. They follow along some of what the US does, but not everything, but they are keeping a close eye on spectrum sharing opportunities. So they're very interested and very closely following what other countries are doing. So again, this is just a smattering of countries that have spoken on kind of their efforts to date, what they're doing. There are many others that I didn't cover that are doing other things. So in summary, Cambium Networks has this wireless fabric, and it does many different things. We have a huge, wide and deep portfolio these days that support many different bands. We work alongside with regulators around the world to try to free up and make spectrum more usable. And spectrum sharing is an avenue that we can do that with. So again, traditional multi-point, point-to-point, point-to-multi-point stuff in unlicensed bands, expanding that role to CBRS, spectrum sharing on CBRS, expanding that role upward to 6 gigahertz and using spectrum sharing there. We have the 60 gigahertz product that was recently released. That's a great localized product because it's high frequency. It doesn't go that far. It doesn't cause interference in many locations beyond the range that's expected. That's a fantastic high bandwidth product, and 60 gigahertz is unlicensed in a lot of areas. So opportunities are there. Other places, it may become a shared spectrum. So we're working with regulators to try and make that happen. As I mentioned, what's not shown on the slide, 26, 28 gigahertz, there's a lot of opportunity there again, and TV whitespace for that matter. So again, all over the place, all over the world, many different countries, spectrum sharing will become a useful tool to drive this growth and access to broadband. There's all kinds of different technologies that can be done. Of course, 3GPP and Wi-Fi 6 those two competing standards, if you will, or I guess symbiotic standards. I think they will be used alongside each other and in place of each other in many different areas. But there's also software-defined radio systems like what we have with the PMP 450 platform that can be used for this too, and used very successfully. We've proven that through the past several years, and we will continue down that path for quite some time. So again, we're adding to that wireless fabric that I talked about by adopting standards where it makes sense. We're addressing the high frequency bands and adding to the portfolio to leverage decades of history as a fixed wireless broadband leader. So I talked a whole lot, and I covered a lot of different topics. And now I'd like to open it up if there are any questions. I don't see any in the chat at this time, but I'll stay on the line for a minute. And if you guys have questions, please feel free to ask them. Open it up and put it in the question box, and I will try to answer them if I can. And being as I don't see any questions coming in, I will sign off for now. And thank you all for attending. And we'll post this in the forum, and you can feel free to ask questions in the forum as well, in our community forum. And thanks again. Bye-bye.